Hi, this is the fourth part of the Earth's motion around Sun video series. So in this video, we are going to do two main things. The first is to transform the coordinates such that the Earth is stationary and the rest of the system is moving around the Earth. And the second thing is to trace the path of Mars with respect to Earth. So let's first do the coordinate transformation. So we know that the Earth's coordinates are earth.pose.x and earth.pose.y. So we have to bring this coordinates to 0, 0. And for that, we have to do the translation by passing the values minus earth.pose.x, minus earth.pose.y. So if we do that, we can see that the Earth is now stationary and the rest of the system is moving around the Earth. Now we want to trace the path of Mars with respect to Earth. For that, we have to get the relative position of Mars with respect to Earth. So for that, I'm going to write a function. Get relative pose const relative pose equal to, I'm going to use the subtract function provided by the p5 vector class. So mars.pose.sub earth.pose. So I have taken the position vector of Earth and subtracted it from Mars position vector. Then I'm going to return the x and y coordinates of the position vector. X relative pose.x, y relative pose.y. I'm going to test this function by calling this in the mouse pressed function console.log get relative pose. I hope we are getting the correct values. Now, to trace the path of Mars, we need to have an array. And in that array, we will be storing the relative positions. So, relative pose array equal to an empty array. And then I'm going to write a function to store the relative positions. Function store relative pose, and I'm going to get the relative pose first, get relative pose, and then I'm going to push the value to relative pose array, relative pose. So I can't call this function in the draw loop, because if I do that, this will result in adding the relative pose to the array endlessly. So I have to have a limit. Max number of pose equal to 200 is my limit. And then I'm going to provide an if condition here. Relative pose array dot length less than max pose. Then I'm going to add this to the array. Then I'm going to call this in the draw loop. I'm going to again test this. I want to print this. So if this is working correctly, then I should have all the values filled in the array. Relative pose array is not a function, so I have to push here. Okay, I have all the values in the array. Now I want to use this array to trace the position of Mars with respect to Earth. So I'm going to write a function called trace. So within trace, I'm going to iterate through the relative pose array, relative pose array dot length I plus plus. I'm going to draw a point. Relative pose array of I dot x, relative pose array of I dot y, and then I have a stroke of white. And then I'm going to call this function intro loop. Okay, we are tracing the value, but we should have an offset here. So offset should be earth.post.x, earth.post.y, and then I should have a stroke weight of 2 here. I'm going to comment the code for drawing sun, and yeah. Now what we want to do is to have this effect where the points at the end should slowly disappear. So here, if we reach the limit, we have to delete the first point. So here, relative post array dot slice 1 comma length. This is the code for deleting the first point. Okay, we got what we want. Then we can also add some code to have this transparency effect. So here, instead of providing white, I'm going to provide 255, and as the fourth parameter, I'm going to map the values. I'm going to map the value I to determine the transparency. So I 0 comma 255, 0 number of max number of posts. So I hope you're understanding what we are doing here. So we are mapping the value I. So the mapping is happening between these two sets of values, 0 comma max number of posts and 0 comma 255. So now we got the effect. So maybe we can increase the number of points. Okay, so we got the visualization. So in the next video, we'll be adding two sliders to control the relative position, relative velocity of the planets, and then change the relative velocity to see how this loop pattern change. So thank you and see you in the next video.